Inquiry, teaching and learning, which is central to the integrated curriculum for science education, should not be an isolated occurrence, but a comprehensive and ongoing approach. However, many teachers hesitate to teach science through inquiry because they did not learn this way themselves, and when they were students or during their preparation to become teachers. Now, inquiry-based teaching and learning can take several forms. Here, students are exposed to inquiry learning through a scientific investigation. In school, students do some form of scientific investigation, but more often than not, they follow a prescribed procedures, prescribed steps of investigation. Okay, so here students are given the opportunity to plan their own investigation and ways to analyze and how they are going to present their finding and conclusion. Now, there are several phases, main phases in a scientific investigation, which are plan, perform, analyze, interpret and conclude, and communicate. For this particular scientific investigation, students are involved in trying to understand Archimedes' principle, and at the start of the lesson, the teacher would try to make connection with students' everyday life by asking questions such as why do heavy steel ships float while a piece of much lighter steel sinks? In fact, why do some objects float while others sink? So we need to make a connection so that what the students are trying to investigate will actually, so that they can relate to their everyday experience. Now, in the first step, they have to formulate a question, a central guiding question that will guide the investigation. And then they go into planning their investigation. So for this particular scientific investigation, the scientific investigation is more open-ended. Therefore, students have to plan their investigation themselves. They have to actually discuss in groups how they are going to carry out the investigation. What are the variables involved? They have to control variables. What are the materials, the equipments that they need to use, and also how they are going to collect the data, tabulate the data, and also interpret the data.
Okay, first question, what is the central guiding question?
What is the relationship between the wave force and the weight of the water?
Okay, very good. We are going to answer the question, what is the relationship between the buoyant force and the weight of the liquid displaced? Or in other words, how does the buoyant force relates to weight of the liquid displaced? Okay, that's the same question. Now the second part is our hypothesis. We have already put up our hypothesis. The first one is buoyant force is equal to the weight of the liquid displaced. The second one would be buoyant force and weight of liquid displaced have the same magnitude, which is basically the same as the first hypothesis, isn't it? But now we also consider the direction, opposite in direction. Okay, opposite in direction. Okay.
Kau nak set up eksperimen dulu ke? Set up dulu. Mula set up objek eksperimen. Kita lukis lah with the aid of diagram.
Masa ikut berat kot. Masa baik stesen lah. Baik buat guliat. Masa sekarang kita buat tumpat macam bulat gitu, kita gelam. Kalau macam kita buat sampai buku yang kata kita pakai tenggelam.
Nanti kalau kita boleh dagang takkan dapat dalam kg kan? Maknanya kalau kita nak tukar pada liquid nak 10 je kan?
Sebab yang lain sebab kita guna weight, kita guna weight, kita guna mass. So yang ni kg, yang lain kita
Kita nak 10 je kan?
Okay class, time's up. Okay, now we are going to actually discuss as a whole class, right? So I want ideas from each of the groups. Questions, what are the variables involved? What is the manipulated variable? This group, what is the manipulated variable? The weight of the object. The weight of the object. Alright, the weight of the object. What about this group? What do you think is the manipulated variable? Manipulated. The one that you change the numbers. you change the density of the fluid? Are we trying to actually look into the density? What is the liquid that we are going to use today? Water. So do we need to change the water with oil and then with alcohol perhaps? No? No? We're not going to change the liquid, isn't it? So that would not be the manipulated variable. What would be the manipulated variable? This group. So you have to say, weight of the object. What would affect how much water is displaced? Is it the weight of the object that you immerse in the liquid? Is it the weight? Yes? The depth of the object that is under the water, is it? In other words, what is that quantity there? The part of the object that is immersed. What is it? The volume, isn't it? We have the manipulated variable. We actually manipulate how much. The volume of the object that is immersed in the liquid, because that would determine how much water that would be displaced. So let's have one group share their design with the rest of the groups. Okay? Group at the back, can you come to the front? One representative from the group at the back. Share with the class how you are going to find out whether buoyant force and the weight of the liquid displaced are equal. Come.
Untuk kami punya eksperimen, kami menggunakan objek yang mempunyai weight yang sama. Maksudnya kami tak ubah dia punya weight, tapi kami ubah dia punya kedalaman depth tadi, iaitu volume. Maksudnya semakin dia semakin dalam, pressure dia meningkat, air yang tersisa tu semakin bertambah. Kami guna rajah sama juga, kerana apabila objek ditenggelamkan sepenuhnya, jadi akan ada liquid yang keluar. So water displace sama dengan buoyant force.
How do you find buoyant force? How do you measure it? GV? Are you sure? Now remember class, the buoyant force is actually the force that is acting upward, isn't it? Okay? Now how do you find the value of FB?
Kita timbang dulu sebab spin dia menunjukkan berat kan?
Timbang apa?
Objek.
Timbang object. Okay, so we weigh the object first. How? How do we weigh that?
Kita
In the air. Very good, Lydia. You measure the object first in the air, and then you have a reading, isn't it? Okay, and then after that,
we weight of the object when we immerse the object in the water.
okay, so therefore the buoyant force would be
The weight and the air.
please.
Faham tak?
Okay?
Kelas?
Very good, thank you.
Apa nak? Maksudnya macam tu.
Do you have to measure the weight in air? Have you measured it? How do you measure it in air? The spring, the balance there. How do you measure the weight in water?
That's the problem.
Then you have
Angkat lagi. Angkat lagi nanti dia jatuh. Tapi kita tengok volume dia sama.
Sekarang ni kita nak ambil yang bahagian kalau kita rendang semua sekali. Kan?
Tak sampai lah.
another reading.
Sampai 40.
Kita tukar nak?
So how many readings did you take? 4 readings? 4 readings, are you sure? One is fully immersed, one is half immersed, maybe? One is 3/4 immersed, maybe? Okay. 6.25. Okay, class. Everybody settle down. Now let's discuss what are our findings. Okay, so this is a very important phase of the lesson, class, which we call debriefing. Okay, so whenever students have done their activities, it is very important that you regroup the students and then discuss what are their findings. Okay?
This is our result after carry out the accommodative principle experiment. This experiment is carried out to determine the relationship between the magnitude of the buoyant force and the weight of water displaced. So our hypothesis for this experiment is magnitude of buoyant force is equal to the weight of the water displaced. The apparatus is set up as a picture. In this experiment, we use two objects, that is rod and stone. First of all, we have to find buoyant force, and after that, the weight of displaced water.
Okay, today I will present about our data of our experiment that we collect. So this is our experiment that we set up. There's a spin balance, load, and a small beaker and a Eureka tank. So the data that we collect is the two conditions. There is a condition of object that is fully immersed and also the partially immersed in water. Firstly, we measure the weight of water, weight of object in air. That is fully immersed 1.10 Newton. And then we measure the weight of object in water, that is 0.95 Newton. So the buoyant force we can get, that is a weight of water, weight of object in air minus the weight of object in water, that is 0.15. So we can conclude that the buoyant force is equal to weight of the water displaced. The hypothesis is accepted.
Now, what are the sources of error can you think of that give the result that is not safe? The water in the Eureka can. So, what about the water in the Eureka can? Okay, so you must make sure that the level of water in the Eureka can is at the level of the openings, isn't it? Because if it's not, then when you immerse the object in the water, it won't flow out. Okay, so you must make sure that the level is at the opening. Okay, so how do you make sure that this group? How do you make sure the level is at the opening? How do you do it? You put water until level. How do you ensure that it is at the maximum level? Okay, so you put in extra water so that it flows out, and then when it stops, then you have that the level is at the opening. Okay, very good. Okay, so maybe those are the sources of errors that you get from your readings because of those two errors. Okay, and remember, while I was looking at your work, okay, most students do not actually convert grams into Newton. Remember, grams is a unit for mass, and we are dealing with weight. Okay, so you need to convert it into kilogram first, and then only multiply it by 9.8. More precise than 10. Okay, 9.8. Okay, so very good. We have done today what is called. Now the second hypothesis is actually the same as the first, except that the direction. Okay, so how do you know it is in the opposite direction? The buoyant force and the weight of the liquid displaced. How do you know they are in the opposite direction? It's lost its weight, isn't it? It becomes lighter. That means something has to support it upward. Here we have Buoyant force and weight of liquid displays have the same magnitude but opposite in direction. What about weight? How do you know it is acting downwards? Because you're saying that they are opposite in direction, isn't it? So how do you know it's acting downwards? Because weight is actually gravitational force acting between the object and... What is a gravitational force? What is weight? Yes, the formula is mg, but what is it? Okay, very basic question. What is weight? Weight is actually a gravitational force. Gravitational force is the force acting between what and what? The gravitational force is weight. The gravitational force is the weight of the object, which is actually force acting between the weight and the object and surface. Remember, okay, force is an interaction. So it has to be interacting with something. So you have weight. Do you have weight? Yes. You have weight? So we are interacting with something, isn't it? Weight is a gravitational force. We are interacting with what? With the earth. We are interacting with the earth. Okay? Remember that, okay? So interacting with the earth, the direction always points towards the center of the earth. Center of the earth. That would be downwards. Alright. Now, let's look at what we have here. Now, after you've done the experiment, the investigation, what you need to actually write a report, okay? And in this document, I have given you guidelines on how to write a lab report. Okay, so you need to do that individually, okay, and then submit your lab report in a week's time.